Have you ever wondered what really happens when you flip a light switch? Instantly, darkness becomes light, almost like magic. We rely on electricity for everything: lights, phones, computers, and more. It's so ever-present we barely notice it until it's gone. But electricity's journey to your home is anything but simple. It travels hundreds of miles through a vast, interconnected system called the power grid. Think of the grid as a network of highways, roads, and streets for electricity. Each part, generation, transmission, and distribution, has a unique job. If one part fails, the whole system can be affected. Understanding this journey reveals the science behind that simple flip of a switch. So, let's follow electricity from its creation to your wall outlet. Along the way, we'll discover the unsung hero, the electrical substation. These buzzing hubs are the key to keeping our world powered. Electricity's journey has three main steps: generation, transmission, and distribution. Generation happens at power plants, using coal, gas, nuclear, water, wind, or solar energy to create electricity. But power can't go straight to your house. It needs to travel far. That's where transmission comes in. High voltage lines on tall towers carry electricity across vast distances. High voltage is like high pressure, letting power travel efficiently with minimal loss. As electricity nears towns, it's still too powerful for homes. Enter the third step: distribution. Transmission lines connect to local networks, those smaller lines you see on neighborhood poles. Distribution brings electricity right to your door. But how does high voltage power become safe for your home? This is where substations come in. Substations are the grid's interchanges, stepping down voltage and directing power where it's needed. They're the essential link between transmission and distribution. Without substations, the system wouldn't work. They ensure the right amount of power reaches the right place every time. Substations truly make the journey possible. Let's zoom in on generation, the start of electricity's journey. Power plants convert energy into electricity using generators, which rely on electromagnetic induction, moving magnets near coils of wire to create current. The key is spinning a turbine, which turns the generator. Fossil fuel plants burn coal or gas to make steam that spins turbines. Nuclear plants use atomic reactions for heat, also creating steam. Hydroelectric dams use falling water to spin turbines, no steam needed. Wind turbines harness the wind, spinning blades connected to generators. Solar panels are different. They use photovoltaic cells to turn sunlight directly into electricity. No moving parts required. No matter the method, the goal is the same: generate electrical power for the grid. Each source, fossil, nuclear, hydro, wind, or solar, starts the journey. The electricity produced is ready for its long trip. But before it can travel, it needs a boost. That's where the next stage begins. The journey from generator to your home is just getting started. Let's see how it moves across the country. After generation, electricity enters the transmission stage, its cross-country road trip. At the plant's switchyard, a step-up transformer boosts voltage to hundreds of thousands of volts for efficient travel. High voltage is crucial. It lets power move long distances with little loss, like high-pressure water in a hose. Special conductors, usually aluminum and steel, carry this power on tall steel towers. Insulators keep the electricity safely separated from the towers. This network forms the backbone of the grid, connecting regions and power plants. If one plant goes offline, power can be rerouted, keeping the lights on. The grid's interconnectedness is its strength. Most of this happens high above us, quietly and reliably. It's a marvel of engineering hidden in plain sight. At the edge of town, electricity arrives at a substation, a fenced area full of metal and wires. Substations are the critical link between high-voltage transmission and local distribution. Their main jobs step down voltage to safer levels for homes and businesses. Inside, massive transformers reduce voltage from hundreds of thousands to just thousands of volts. Substations also act as control centers, directing the flow of electricity. Switches and circuit breakers let operators reroute power as needed. Buses, thick metal bars, carry current to different circuits. Every wire and device is part of a carefully designed system. Substations may look chaotic, but they're highly organized. They prepare electricity for its final journey to you. Substations are the grid's traffic cops, controlling where electricity flows. Large switches open or close circuits, letting operators direct power or shut down lines for maintenance. This flexibility keeps the grid resilient. If one line fails, another can take over. Substations also protect the grid from danger. Faults, like a tree falling on a line or a lightning strike, can cause dangerous surges. Substations use giant fuses and circuit breakers to detect and stop these surges instantly. Circuit breakers trip in a flash, stopping dangerous currents before damage occurs. This protection prevents equipment damage and blackouts. Every switch, fuse, and breaker is there to keep the grid safe. Substations are always on guard, ready to respond in milliseconds. Their quick action keeps power flowing safely. Without these protections, the grid would be far more vulnerable. Substations are the silent guardians of our electricity. The most iconic substation equipment? The transformer. Transformers change voltage, stepping it up or down, using electromagnetic induction, but with no moving parts. Inside, two coils of wire around an iron core transfer energy by magnetic fields. Fewer turns in the secondary coil mean lower voltage, a step-down transformer. Large transformers hum as they work, cooled by mineral oil and metal fins. They come in all sizes, from bus-sized giants to small neighborhood units. The final step-down transformer brings voltage to safe levels for your home. Every device you plug in uses electricity that's passed through several transformers. These devices make the grid flexible and efficient. Without transformers, modern power distribution wouldn't be possible. Safety is the top priority at every substation. High fences and barbed wire keep people out. High voltage is deadly. Crushed gravel covers the ground, preventing weeds and reducing shock risk. Equipment is spaced far apart to prevent dangerous electrical arcs. Insulators and careful design keep electricity where it belongs. Workers wear protective gear and use insulated tools for every task. Strict procedures and grounding grids ensure safety during faults. Every detail is designed to protect workers and the public. Substations are built to keep everyone safe, every day. The power grid is evolving, and substations are at the heart of this change. As we add more renewables and electric vehicles, substations adapt to new demands. Each substation is custom designed for its community's needs. The future brings smart substations, equipped with sensors and digital controls. These can monitor the grid in real time and reroute power automatically. Smarter substations mean a more resilient, efficient, and cleaner grid. Next time you flip a switch, remember the journey electricity took. From power plant to substation to your home, it's a story of science and engineering. Substations are the unsung heroes, powering our lives and our future. That's the real magic behind the switch.